Hello, today we will learn about measuring resistance. When the volt ohm meter is used to measure resistance, what actually is measured is a small voltage and current applied to the component. There are 5 ranges. An out of resistance reading will indicate a single one digit. Remember, K means multiple the reading by 1000. Operating voltage should be removed from the component under test, or you could damage the volt ohm meter at worst, or the reading could be false at best. When measuring resistance, there is a small voltage supplied by the meter to energize the component. The red probe lead would have the positive voltage. The volt ohm then measures the voltage and current flowing through the component, and the resistance is calculated using Ohm's law, which will be covered later. You can go through the 5 ranges. 200 will read up to 200 ohms, 2000 will read up to 2000 ohm, 20k will read up to 20,000 ohm, 200k will read up to 200,000 ohm, while 2000k will read up to 2 million ohm or 2 mega ohm. If their power is removed from the circuit, there is little danger that the volt ohm could be damaged. So you need to remove the power before starting the test. Now let's look at an example. Measuring resistance. Disconnect the battery from the board. Remember to measure resistance. The circuit should be unpowered. Put the 100 ohm resistor in place. No additional wires are required. Select the 200 range and touch the probe leads to either side of the resistor. It will read 98.0. Now, if we look here, let's rephrase the probe leads and observe the reading. As you can see, there is no difference. It's the same reading, 98.0. So this means that the resistor doesn't have a polarity, and you can measure at any of these sides. Now let's look another example where we can discuss the resolution. Using the 100 ohm resistor, let's measure the resistance using each of the other ranges. This is the 2000, as you can see, 0, 89, and in 20k, as you can see, 0.10, the 200k, 0.1, the 2000k, 0.00. So it's like out of range, and we can't possibly measure that resistor, which is 100 ohm, using the 2 mega ohm scale. This will be seriously wrong, and we won't get a value. Note that the resolution of the reading decreases as the maximum ohm reading increases, down to the point where it is difficult to get a good resistance reading, which is in this example. Now, if we look at another example, as you can see here, using the 1 kilo ohm resistor and the 200 range, this is what we get. We used 1 kilo ohm, which is 1000 ohm. It's a way much larger than 200 ohm range, so it displayed 1, which means that there is a reading that is out of range. We must find the appropriate range to measuring the 1 kilo ohm. So if we use the 2000 ohm reading, it will give us 984 ohm, as you can see here, which is the best resolution for measuring the 1 kilo ohm. So you must choose the resolution wisely, otherwise you will get error, or you won't get an accurate result, and this will let's say that this will damage your calculations. because you mischoose the right resolution. So you need to try different resolutions to get the best value with as minimum as possible zeros in the left side, and in that case the 2000 did the trick for us. Now use the 10 kilo ohm and the 100 kilo ohm resistor. First, determine the appropriate range to use for each resistor. Second, make the resistance measurement. Third, using higher ranges, predict the reading and confirm your prediction by taking the measurement. This is a good practice that you should do, and these are a really simple, let's say a really simple steps that you can apply. Now, just for fun, use the volt ohm meter to measure the resistance offered your different body parts. The voltage and current used by the volt ohm meter is not dangerous, so you can measure the resistance through your body. Discuss your observation and how your measurement techniques could influence the readings you get from the volt ohm meter. And I think that this is a really fun practice. Probes across individual finger will read around 1.8 mega ohm. Probes held between thumbs and finger, one in each hand, will measure 1.4 mega ohm. Probes from the skin on the ankle and skin on the hand will get you a scale of reading. Dry skin versus moist skin. Dry 1 mega ohm, moist 96 kilo ohm. Lightly touching hit probes compared to a firmer grasp on the probes. Light is 1 mega ohm, while firm is 300 kilo ohm. The point here is that body contact with the probes during measurement can influence the ohm meter reading and should be avoided, particularly when measuring high values of resistance. You can bring this up again and try it yourself at home. You will know that once you touch the two probes, it will display a resistance, so you need to avoid direct contact with the resistance when measuring it, since this will damage your reading or give you a false reading. So please take care of this very important note when using the volt ohm meter or the digital multimeter to measure resistance. Hello and welcome to this new lesson in which I will explain to you how to measure resistance. Measuring resistance is a very easy job. You just need to go here to the resistance mark, and we have from 200 to 200 mega ohm resistance. You can choose any of these, but if you don't know, you can start big, then move down to the low resistance if you don't know the resistance that you are measuring, and if you don't have a clue about the measuring range. So first thing is going here and choosing the connectors. The black will be in the common and the red will be in the volt ohm hertz diode measuring. And as I mentioned earlier, just need to turn it on, then bring these two wires, and let's bring the resistor. This is the resistor. Place your hand on one end and the other end leave it free, and as you can see, it's measuring a number with 0.0 etc., which means that we have a smaller resistance. Let's move it to 20 kilo ohm. Now if we measured, as you can see, we have 10 kilo ohm resistor, 9.9 kilo ohm resistor, which is basically a 10 kilo ohm resistor. Now the other way to measure a resistance value is by downloading any of the resistance color coding apps on your mobile phone and use these colors, as you can see, brown, black, orange and gold, to find the resistance value. Resistance might come in many shapes. This is a typical, normal, commonly used resistor, while this one that you are seeing here is called heat resistor. It can withstand up to 5 watts, and its value is written R4 R7, so 4.7 kilo ohm resistor, and in this case 4.7 ohm. As you can see, the R means the ohm, but when R is placed between two numbers, it means that this is replaced with a dot. Now let's try to measure this resistance. Hopefully it's working. Now, as you can see, it has a very low value. We have the result 0.01, so we need to move down to the 200 ohm measuring range. As you can see, now we have the right measuring, which is 5 ohm. As I mentioned earlier, it's 4.7 ohm. Remove the R and place dot, so 4.7 ohm. So it's basically 5 ohm, the same as measured in this digital multimeter. That's it for measuring a resistance. It's a very easy job. Even if you don't have a digital multimeter, you can measure it using the color coding on any website. Search Google for it. And as I mentioned, it comes in many shapes. These are two of the shapes. This one is heat. It can withstand heat up to 5 watts. When drawing 5 watts, it will heat up. If you touched it, you can sense some heating that's coming out of it, but it's well protected. That's it for how to measure a resistance. Now let me talk about how you can check if a resistance is working or not. Now the first step would be using a digital multimeter to measure the resistance value for sure, and if you have color coding, you can check the measured value with the color coding value. If they were not the same, this means that this resistance isn't working. This is the first step. The second step, if the resistance is black or exploded, it's not working, so it's obvious. So you have to go back to the data sheet and know its value to replace it. These are the two main things that you can use to check if a resistor is working or not. Basically, the digital multimeter is the best way to check that. The second best way is by using color coding and comparing it to the digital multimeter reading. Otherwise, if it's exploded, or if it's in black, or if it's burned, or if you can smell a burn around it, it means that it's not working, so you have to replace it with another one. If the colors are there, then you can simply know using the color coding the resistance value and replace it with another one. If the colors aren't there because it's burned out, you can go back to the data sheet and replace it. Hello and welcome. Today we will look at circuit diagrams basics, electronic roadmaps. Basically, each diagram will contain one of these components: resistors, ground, capacitor, inductor, diode, transistor, integrated circuit, and other miscellaneous components. So you have probably tried to build a circuit using one or more than of these elements, or you searched Google for a schematic and you see a lot of the components including these, and you tried to build a circuit yourself. Today I will help you with that, and we together will build a very small but useful circuit. There are many diagram symbols used to symbolize the various electronic components, and there are minor variations in the individual symbol to represent variations with a component class. We will discuss and introduce a basic working knowledge of circuit diagrams. Circuit diagrams are roadmaps that show the pathways that current can take from the current voltage source through the individual components of the circuit to accomplish some task and return to the current voltage source to complete the circuit. The diagram symbols that will be covered are just mentioned here, and you might want to buy these components so that you can understand them in a better manner. Let's look at this circuit. This is a remote decoder circuit, as you can see here. This is the integrated circuit or the IC. This is a relay module, power supply, which give us 9 volt. This is ground, this is transistor, this is a resistor, and as you can see it has a lot of components. This is a switch, this is a regulator, this is a diode, and this is our battery. That switch is used to turn on and off that circuit. This is a simple example of circuit diagram. In this case, the circuit decodes the signal sent by a TV remote control and turns on and off electrical relays switches in response to the keys pressed on the TV remote. This diagram is a really simple one, and these are the four, as you can see here, these are the four switches that we can use. This one, this one, this one, and this one. So depending on what we press on the remote control, one of these relays will be turned on or off. Now we will examine the simple circuit components. This symbol on the left is for fixed value of resistance, this one. The symbol on the right shows a potentiometer or a pointer that can be moved across the resistance to vary the resistance. We must point out that using various resistance is very common in volume controls, on audio equipments, dimmer light for rooms, and a lot of other examples. Generally, a symbol with a pointed arrow associated with it represents variable or changeable component. Any, not just the resistor, any other component with an arrow or a pointer will represent a changeable value. Now if we look here, grounding through at first appearance is a simple topic. This is for ground. This is the symbol that we use to represent ground. It really does have some differences as represented by these two symbols for ground. A ground is a common return path to the current in a circuit to the voltage current source. By convention, the ground connection is hooked to the negative pole of the power source, so in reality the ground is the originating source of electrons. This seems to be backwards, but this is the standard convention. In the early days of automobiles, the positive side of the battery and other voltage current sources were connected to ground. This is not true today. The term grounding probably comes from the safety term related to connecting an electric device to a metal rod driven into the earth to provide a safety path for stray current to flow into the earth, and not through the operator's body. For instance, many high structures have lightning rods that are hooked to grounding rods driven into the earth so that in the event of a lightning strike, the dangerous voltage and current from the lightning strike flow harmlessly into the earth and not through humans in the place. There are two basic types of grounds as represented by the two symbols. The symbol on the left that looks like a shovel represents a ground connection to an earth ground. Represents a ground, as you can see here, it represents a ground connection to the earth ground. Commonly there is only one connection between an electrical device and an earth ground, and that connection is primarily for safety. This could be argued that the earth ground is also important for proper RF performance, but the discussion can be done in more advanced courses. The symbol on the right that looks like a rack or pitchfork, as you can see here, represents a chassis ground. A chassis ground is the metal box or foundation that the electronic device is contained in. The symbol actually represents multiple connections between components and the chassis. The chassis ground is used to provide the common path for current to flow back to the power source to complete the circuit. I know that this is too much to understand, but you need to get a clue of grounding and what it really means. Now let's look at these two capacitors. This is the symbol that is used for capacitor, fixed and variable capacitor. The function and operation of capacitor will be covered in some details a little later, but you can describe the internal component of the capacitor based on the symbol. It consists mainly of two plates or two metal plates separated by a space, as you can see here. One metal plate and the other one, then there is a space between them. That is basically what a capacitor is: two conductors separated by a non-inductive space. To give just a brief description of a capacitor, we must mention that capacitors can be thought of tiny and very temporary storage batteries. Capacitors store electrical energy in electrostatic field between the plates. Anyone who has combed their hair or have taken clothing out of a dryer knows what a static electricity is. You can make a connection and test that yourself. Now if we looked at here, we can see the inductor symbol. We must point out that if there was an arrow, the inductor would be variable, as we mentioned earlier, based on the symbol. Let's try to describe the inner structure of that inductor. We can see that consists mainly of a coil of wire, or a coil of wire with something inside the coil. As a brief introduction to inductors, you need to understand that inductors store electrical energy in a magnetic field that is formed around the coil here. When current passes through it, so if we pass current through here, it will store energy in a magnetic field around that coil. Most of you are familiar with the Earth's magnetic field. One theory is that the Earth's magnetic field is formed because electrons are moving within the molten metal that makes up the Earth core. The same that happens at a very tiny scale in inductors in a circuit. When you allow current to pass through the wire, it will generate a magnetic field around it that will theoretically store energy. These three symbols are for diodes. There are a number of diodes for various purposes, and as you can see, the regular diode, the Zener diode, and the light-emitting diode, the one that turn on and off a light once activated. And these three diodes are used widely. Now if you look here at the transistor, as you can see, this is an NPN transistor, a PNP transistor, and a FET transistor. There is a trick to help you identify the type of bipolar transistor, which is looking to the direction of the arrow, as you can see here. If the arrow is pointing out, it is not pointing in, that is NPN transistor. And if the arrow is pointing in, it is pointing in proudly, that is PNP transistor. On the FET, the direction of the arrow identifies the material of the junction. In the illustration, the arrow is not pointing in, it's pointing out, therefore this represents an P junction FET. Now let's look at integrated circuit. As you can see, this is its symbol, this is how it looks in real life. By their very nature, integrated circuits are a collection of components that perform a specific function. It is not necessarily to know what goes on inside the IC, just how the IC interfaces with the rest of the circuit. Therefore, the symbol provides only information on which pin of the IC is connected to the surrounding components. Sometimes there is a descriptive label on a pin, for instance G&D for ground and VCC for the power source. Now let's look at the final element. As you can see, these are miscellaneous elements. This is a battery, a speaker, a voltmeter, this is a fuse, and this is antenna, and this is amp meter. That's it for circuit diagrams and basic electronic components symbols. Hello and welcome. Today we'll talk about the resistor in more details. We will take a good look at resistor defined or resistance defined, resistance values, ohms, color code interpretation, power dissipation, and we will look at resistors in circuits, series, parallel, and mixed. This is the resistor symbol as we mentioned earlier. Now let's look at the first thing which is resistance defined. Resistance is the impediment to the free flow of electrons through a conductor. Friction to moving electrons. Where there is friction, there is heat generated. All materials except some resistance, even the best of conductors. Unit measured in ohms. So we measure resistance in ohms from 1 divided by tenths of ohms to millions of ohm. Now let's look at resistor types. There's the fixed value, the variable value, the composite resistive material, the wired wand, and two parameters associated with the resistors, which is resistance value in ohms, power handling capabilities in watts. So these are the two most important factors that you must take care of when mentioning a resistor or dealing with a resistor. Now if we looked here, all 100 ohm resistor, this is 100 ohm, that one, and that one, they came in different sizes as you can see, so they can handle different amount of power. As you can see, the diameter of each one is different than the other, but they all represent the same value, which is 1000 ohm. Now let's look at this and know the different sizes between composite and wire wand resistor. As you can see here, composite types. All of these resistors could have the same resistance value even though their relative sizes vary widely. So as we mentioned in the previous example, these all have the same resistance, which is 1000 ohm, but they come in different sizes. The same is here. Now if we looked here, this is a fixed resistor. As you can see, this is how it looks, and this is another shape. While in variable resistor or potentiometer, as you can see here, that we use in most of the audio devices, this is how it looks. This is its symbol, and this is how it looks in real life. Now what really inside a resistor? As you can see here, this is a resistor open. There is a ceramic tube, a metal end cap as you can see here, and a coating, two connecting wires in the two terminals, and here we can see the printed values. And there is also color bands that represent the value of the resistance. If you don't have a volt ohm meter, you can know its value from the color bands. Now let's look at reading resistor color codes. First, you need to understand that each of these color has a meaning. The first one is the first band, this is the second band, and this is the multiplier, and this is the tolerance. Now we need to model how to read a resistor color code with in practice using a 1 kilo ohm resistor, brown, black, red, and tolerance band. Let's look at that 1 kilo ohm resistor. 10 resistor, so gold or silver band is at right, so you need to let that band which will be either gold or silver in your right side or right hand side. Note the color of the two left hand color bands, which are here, the green one and the blue one. The leftmost band is the left hand value digit. The next band to the right is the second value digit. Note the color of the third band from the left, which is yellow here, as you can see. You must know its color. This is the multiplier. Multiply the two value digits by the multiplier. So we will get a 2 digits from here, then we will use this multiplier to multiply them. Let's look at, let's say, a more solid example. But first, let us look at this color codes. If it's black and existed in the first digit, then its value will be 0, and so on for other colors until you reach the white one, which is 9. If it's in the second digit, it will have the same value, while if any of these colors existed in the third band from the left, it will be that multiplier, as you can see, 1, 10, 100, 1000. And depending on whether the right hand band is gold or silver, you can add a tolerance of 5% or 10%, or in case of no color band, it will be 20%. This is a very simple sorry. Now let's look. If we have 1 kilo ohm resistor, brown, black, red, and tolerance band, let's orient the resistor with the tolerance band to the right, the gold or silver band. If there is no band, we mentioned that it will be 20% tolerance resistor. Let's orient that resistor so the band are toward the left. Take note that the two significant digits of the resistor value are going to be represented by the two leftmost color band. Note that the leftmost band is brown, which translates to a value of 1, as you can see here. Brown means 1. And we must note that moving left to right, note that the next band is black. Black means a 0, as we say, let's say this is the black one, it's 0. This is the second digit. So now continue moving left to right. Note that the multiplier band is red, which translates to the multiple or multiplier of 100. So multiply the 10 times 100. It will equal 1000 or 1 kilo ohm. This is a really simple method to measure different values of a resistor without using a digital multimeter. Now, reading resistor color codes, practical problem. If we have an orange, red, yellow, violet, orange, brown, black, brown, black, green, red, blue, gray, orange, white, orange. I need you to get the value of all of these. Take a 5 to translate these values using this table. I will upload the course material so that you can use them. You can use these slides to gain more knowledge. The results will be 3.3 kilo ohm, 47 kilo ohm, 100 ohm, 1 mega ohm, 2.2 kilo, 68 kilo, 39 kilo. Please pause that video and solve this problem before going any further. In the next lesson, we will discuss power dissipation in a resistor.